Okay, by now you've watched the lesson introduction for lesson 2, and now we're going to demonstrate the activities you're going to be performing when you come to the lab. When you come to the lab, you're going to be creating some splices using, you're going to be splicing some conductors together using wire nuts, butt splices, and then a combination of solder and heat shrink tubing. So I'm going to demonstrate those 3 activities here just so you'll have an idea of what you'll be doing when you come to the lab. So the first thing I'm going to do is I've got 2 conductors here that I'm going to be splicing together. You can see that they're covered in insulation, the conductors on the inside. So I'm going to pick these up, and the first thing I'm going to do is strip some of the insulation off. And you need to be careful when doing this. If you use the wrong cutter, if you use a cutter that's too big, it may make it difficult to pull the insulation off. If you use one that is too small, you could actually damage the conductor. So what I've got here is a pretty standard wire stripper, and if you look here, it etched into next to each groove, you can see a number etched into the body of the stripper, and what that's showing you is the wire size for each one of these grooves. So what I have here is a 16 gauge wire, so I'm going to use the slot labeled as 16, so I know that the cutter is the right size for this size wire. So I'm going to pull in here and squeeze that together, give it a little twist, and pull the insulation off. And so I'm just going to kind of twist those strands together. So what I've done is strip the insulation off and left just a bare conductor. So I'm going to do that on this wire, and then on this one I'm going to do the same thing. Again, I'm going to put it in the groove marked 16, and I'm stripping about a 1/2 inch of the insulation off just to give me enough room to work with. Again, strip the insulation off, twist the strands together, keep it so I don't have any stragglers sticking out there. So when I'm using a wire nut, you start out by putting the wires kind of side by side in this fashion. I'm going to twist them together. You don't have to twist them together real snug or anything, but just kind of get them all together into a single conductor. And I need to select the right size wire nut for this size conductor. And these are 16 gauge conductors, so I don't want to use a wire nut that's too big, because if you try to put it down on there, it'll be too loose and it could fall off. Or if I use too small a size, it actually won't be over the conductor good enough to hold everything together. So using 2 16 gauge conductors, the gray wire nut is sufficient in size to hold 16 gauge wires together. So all I'm going to do is put the wire nut over the wire and then start twisting in a clockwise rotation. Just kind of twist it till it gets good and tight. And you notice there's no bare conductor hanging out of here. If I would have stripped too much insulation off, the conductor could have been out here exposed, and we don't want that. So with everything twisted together, I should be able to test this, and that's a good solid splice. So next we're going to look at using butt splices, and I've got 3 butt splices here. I'm going to grab a couple more conductors here. Again, these are 16 gauge conductors, so I'm going to use the 16 gauge slot, strip about a 1/2 inch off. Twist that together. And do that again on my other conductor. Okay, so this one I'm going to do a little bit differently. With the wire nut, I put everything together and kind of twist it together. With butt splice, works in a different way. And like I said, I've got 3 different sizes here, and depending on what size wire you're using, it depends on which size and what color you use. But since I'm doing 16 gauge wire, I'm going to use the blue butt splice. I'm going to put the other 2 out of the way. So how butt splice works, I've got a plastic insulation on here, and I don't know if you can see inside, but there's actually a metallic barrel inside there. So when you slide the wire inside that barrel, then I'm going to use a crimping tool that will actually crush that barrel and do a physical pinch on the wire to kind of hold everything in place. So what I've got here is a pretty standard wire crimper, And this particular one is color coded. It shows that if I'm using a red butt splice, which I had over there, I would use this groove. If I'm using yellow or blue, it tells me to use this groove up here. So since I'm using the blue butt splice, I'm going to hold this in the blue groove, and notice I've got the point here where it's going to, when I squeeze this, it's actually going to smash that barrel on the inside. So I don't want to do it right out here on the tip. I want to be sure I'm actually pinching the barrel. So I'm going to take my first wire here. I'm just going to slip it inside there, and you want to be careful not to push all the strands. If you hit it in there just wrong, it could actually bend some of these strands out, and they could end up poking outside of the butt splice. But you want to be careful. Just kind of slip them in there. Make sure you don't hit the strands, and it'll go in there and stop. And there's a little stop point in there. And once it's in there, then I can squeeze my butt splice. Just kind of give it a good squeeze, and you can see that it actually puts a dent in the outside of the connector, but it's actually crushed the wire inside there, and it holds it in there pretty snug. So I'm going to do the same thing on the other side. So I'm going to make sure that's on the barrel. Take this wire, slip it inside there carefully. Now that it's in there, kind of squeeze. And you can see that I've got it on both sides. One crush this side for this wire, and you crush this side for this wire. And now the electrical connection becomes through the conductor, through the barrel to the other conductor, and creates a good solid splice. So the last type of splice we're going to do today is the solder and heat shrink tubing. So what I'm going to do here, we're going to do a couple different things on these conductors just for demonstration purposes. I'm going to go ahead and strip both ends of these wires. Again, these are 16 gauge, so I'll get about a 1/2 inch. Pull the insulation off. I'm going to do this on both sides. Okay, I'm going to bring in a little tool here that's going to hold the wires for me while I solder them. And so the first thing I'm going to do is a procedure called tinning. So I'm going to tin the ends of the wire here, because what I've got here is it's a stranded wire, so this could actually strand out and come out in different places. But when I tin this, it's actually going to hold all that together into just a single hard conductor here. So I'm going to twist that together. So now I've got everything twisted. I'm going to hold it in my holder here, just kind of have it in place. And what I've got here is a soldering iron that's already heated up. So it's a pretty standard soldering iron. You got the handle in, and then you've got this end down here is the actual iron end, and it's hot. It's in excess of 400 degrees, so you do not want to touch that, because just touching it could give you some pretty severe burns. So what I've got here is just some standard rosin core solder. Inside this solder is it's a rosin. It's helped with the oxidation, gives you a cleaner solder without any oxidation. So what I'm going to do when I solder, one of the things you'll learn if you do this very much is that solder follows heat. So you want to be able to transfer the heat from the iron to the conductor so that the solder will feed into the conductor. So I want to have some good heat transfer. So what I'm going to do is just touch my solder to my iron and just put just a little bit of molten solder on there, and that's going to help me when I touch it to the conductor. That's going to help with the heat transfer into the wire or into the conductor. So I'm going to feed out a little solder here. I'm going to put my iron on the wire. That's going to heat the wire. I'm going to feed solder in. You'll see that solder kind of feeds into the wire. and I actually held that on there a little bit too long. You can see where it started melting the insulation away, and if you do it fast enough, you can not melt the insulation away. We'll try it again on this other one. So I'm going to hold this, twist this together, hold this in here. I'm going to clean my soldering iron. Over here on my soldering stand, I've got a sponge, and the sponge is just damp with water. It's not sopping wet. You just kind of wet it down and wring it out, and that kind of gives you a place that you can clean the solder tip. Make sure you don't have any old solder that could contaminate your fresh solder in your new soldering joint. So again, I'm going to just tap a little bit of solder onto the iron. Put it on here, feed a little solder in there, and I've got a nice clean solder. In just a few seconds that will cool off. You can see that now the strands are all kind of held together in one solid conductor. So to create a splice using solder, and again I'm going to use my tool here to hold this, but what I'm going to do is we're going to put these wires or these conductors together, and then we're going to feed the solder in, and then I have a piece of heat shrink tubing that we're going to slide over it, and that's what's going to insulate the splice once we're done. So what I'm going to do is slide this heat shrink tubing over the wire just a little bit. In this lab, you could actually keep the heat shrink tubing off and then solder everything together and slide it back on there. But if you were actually doing this in the field, you probably, chances are you wouldn't have that luxury, because heat causes this tubing to draw up and shrink around the conductor. So if you get too much heat in it, this could actually shrink up and not allow you to slide it on there. So just try to keep this a little more realistic. We're going to leave the heat shrink tubing on here, just pulled back from the solder joint a little bit, and then we're going to slide it back up there and shrink it up. So for this step, I'm going to kind of just push my wires out here, just kind of fray the strands a little bit. That's going to help me when I push these together. So now I'm going to take these wires and I'm going to push them together like this, and I'm going to start kind of mashing everything back down. I'm going to twist it together. So what I have here, you can see I got everything kind of pushed down nice and tight. So now what I'm going to do is like when I was tinning the wires, except I'm going to run the solder in here where I've got the wires joined together. I'm going to clean my solder tip. Pull my solder out here. Put a little solder on my iron just for good heat transfer. And I'm going to feed the solder into the wire. And it's a nice shiny solder joint. Because you could have, if you're moving things around when you're trying to solder it, you could actually create what's called a cold solder joint, and you could recognize a cold solder joint by the appearance of it a lot of times. This is a nice shiny solder joint. If it's really dull in appearance, you may want to reheat it, feed a little more fresh solder into it to kind of give you a better connection. So now, pull this out of here. Everything's cooled off. So now I'm going to take my heat shrink tubing, I'm going to slide it over the joint for the splice. I've got it covered up, and then what I have here is a heat gun. All this thing does is like a blow dryer, except it blows extremely hot air. I'm just going to turn it on and blow hot air across this heat shrink tubing. You should be able to see it draw up in the video here. splice with soldered, and then we've got our heat shrink tubing that makes for a really strong splice and a really good connection. So as before, like I said, this is what you're going to be doing when you come to the lab. So if you have any questions or comments, please post them on the discussion board or use the contact information in the class to give me a contact. So thank you.